Hello, on behalf of Sigma-HSE, thank you for joining us today for our webinar covering hazardous area classification. We want to give everyone an opportunity to jump into the session, so we will get started in about 2 minutes. Hello again, everybody, and thank you again for joining us today for our hazardous area classification webinar. I am Mark Yukich, U.S. Technical Development Manager at Sigma-HSE, and I will be your host today. I have about 10 years of process safety industry experience. That experience includes combustible dust, flammable vapors, and chemical reaction hazards, and steps to mitigate those hazardous materials while in process. Our team excels in taking the time to understand the pain points for our customers related to process safety. If we don't have the tools to assist, we will ensure that you are handed off to a team that we trust to bring value in meeting your safety goals. Please feel free to contact me directly anytime should you need any assistance. Sigma-HSE is a global engineering firm with technical experts supporting companies around the world by providing actionable solutions to protect, enhance, and optimize their process. Our goal is to allow your team to focus on what really matters: protection for your people, business, workplace, and environment. Sigma-HSE has offices around the globe with technical offices in the US, UK, and India to provide your safety team with process safety support. In addition, we have labs that test flammable vapors, combustible dust, and chemical reaction hazards. Our services include consulting, testing, and training with an overall mission to tailor a strategy that will fit the needs of our customers by guiding the management of process safety risks and meeting regulatory compliance requirements. A number of our common services are noted in this slide, but always feel free to contact us on ways we can customize a solution that will accomplish your safety goals. In this webinar, we will discuss hazardous area classification. This webinar will explore when it's necessary to go beyond simple zoning, how to manage difficult outcomes, and how supporting evaluations can help refine your results and reduce unnecessary zoning. Please note, as a follow-up, we will be sending out the playback of this webinar directly to all of you. Also, we will have time for Q&A at the end of the session. Feel free to add questions to the questions section during the training, and we will address those at the end of our program. Vinny Samoys will be our process safety consultant leading our discussion today. Vinny, I will turn it over to you.
Thank you, Mark. My name is Vinicius Simões. I have over 24 years of experience in process safety and engineering in general. Some of the areas that I have been working for the past 24 years are facility siting, incident investigation, hazardous area classification, all kind of hazard assessments, DHA, PHAs, and PSM auditing as part of it, besides other auditings. I try to combine a little bit of a technical approach with a collaborative approach with our clients to actually be able to be sure that we tailor the solutions that meet their needs. And that webinar is going to cover some of it. Some of it is going to be exactly how we went a little bit just beyond the regular scope to actually try to achieve a little bit of a better value for the study, right? So in a nutshell, what we're going to cover today is a quick introduction to hazardous area classification, just basically what it is, what standards are used, and then talk a little bit about the hazardous area classification process as a whole, and then why would we go beyond zoning, and that will include some practical examples. So the outline it looks very simple and very standard, and we're gonna go where we go beyond when needed, right? So a quick introduction to hazardous regulation. The first question that we ask always is why? Why are we conducting, right? Most of the studies we have always heard that question before. Why are we doing the study? Why is required? So the main points that we need to clarify that why we do a hazard calculation, first of all, is to prevent fires and explosions, right? You identify locations where explosive atmospheres are going to be present, and then prescribe some suitable electrical equipment installation methods for those areas. What it does is that allows me to prevent ignition of hazardous substances on those locations, which could result in injuries, fatalities, and equipment damage, right? The second thing is ensure regulatory compliance, right? Regulations such as OSHA, NFPA, ATEX, IEC, all standards require that hazardous area classification be done, or basically they tell you that areas be properly classified and that only applicable equipment is used in that area. So the compliance, of course, helps you against liabilities, fines, shutdowns, or even just be sure that your staff is actually working safely into that location, right? It also helps you guide which safe equipment selection and installation we need. So, for example, it lets us know if there's some locations where we're going to need explosion proof, intrinsically safe. Do we need purge panels for the different zones, right? So all of this is there. And then once installed properly, this is a way further to reduce ignition risk, right, based on your hazard. Of course, we're also going to be in that way. Once we do the study, we can document and manage our risks. So the classification results in the documentation basically it can be a report, can be class drawings, it can be basically a way for you to understand where your hazards, where your zones that you need to be concerned about, and then pass this along for safe maintenance, ongoing management of operational risk over the life of the facility, right? And then the last but not least, we're protecting personnel and assets, right? Just by ensuring and pinpoint where the safe controls are needed the most. So the facilities are better equipped to protect the staff and minimize your property losses. So all of those are things that are covered into when you do a hazard classification. The next question is like, how do we do this, right? There is fugitive dust, vapor, or any kind of combustible material can lead to three hazards classification, right? The first one is electrical classification, right? The idea of that electrical classification is to basically determine where required specialized electrical equipment is present or is going to be required to prevent thermal or electrical energy capable of igniting a dust cloud, igniting a flammable cloud. So this allows us to prevent a dust layer from reaching its ignition or self-heating temperature to do that. The second classification is going to be fire hazard area, right? This means it's separated from other areas. We need to do either manual or automatic fire protection so we don't let this escalate. So that's basically what it is. And the last but not least is the flash fire hazard area, which is a deflagration hazard area. It's separated from other areas. It can be by segregation, it can be by deflagration venting panels, and egress that withstands overpressure. So all of those are the three classifications that we have, right? And then how do we achieve? What do we know what is in one location, what is not, or what can be present or not? So what ignition sources we need to consider, right? That's the major question. So NFPA recommends that unless you can prove that ignition source does not exist, we need to account that those are present. And that can be hot work. That's why a lot of times we do hot work procedures. So you will avoid having hot work present in the areas when there is operations going. Trucks, industrial trucks, they can be like ignition sources, hot surface, like ovens, but then you got open flames like flares, fuel fired equipment, heated equipment. I mean, when we talk about the DAJ webinar not too long ago, we're talking about testing. And one of the testings that we do is the auto ignition temperature, right? So at what temperature does that dust ignite itself? And all the materials will have that. And we're going to talk about a little bit about this a little later on. But in a nutshell, what we need to do is that ignition sources need to be considered as long as we cannot prove that they're not present. For example, if you do not have open flames on your site, then it's not going to be something that we consider, but all of this is part of the assessment. Okay, once we get this general idea, why do we do what we need to consider, which standards actually tell me how to do it or what to do? There is a couple different apply standards that we normally use in the US, being that the National Electrical Code, National Electrical Code 500 tells about class division groups. National Electrical Code 505 and 506 talk about zone system. NFPA 497 is for flammable liquids, gas, or vapors. 499 is for electrical area classification guidelines for dust. And then if you ask legally what is the requirements that we have, OSHA has two, 307 and 407, that basically they just tell that we need to classify our hazardous locations. So we basically need to determine what are those locations, right? So what are we talking about at the beginning when we talk about class, division groups, etc.? So when we take into area classification, there's three classes that we need to classify. Flammable gas, flammable or combustible vapors fall under class 1. Combustible dust falls under class 2. And combustible fibers or flyings falls under category 3 or class 3. If we do not have any of those in there, then it's unclassified. That's the importance that we need to do this assessment and look into what they are and what they're going to be present for me, right? So the next one, we're talking about class 1, which is going to be based on NFPA 497, which are going to talk about flammable gas, flammable vapors, flammable or combustible vapors, right? So the first one is that we have like different settings for each one of them, and we're going to have different applications for each one of them. So the first one, which is going to be on section 4.2.1 on 497, it talks about lighted air gases. So what is important with those is that they tend to dissipate very rapidly into the atmosphere. They are not going to affect as great as an area as a heavier than air gases or vapors, but when in enclosed space, such gases can really accumulate and ignite near the ground, right? So when they are cooled sufficiently enough, they could behave like a heavier gas and then absorb heat from the surrounding atmosphere. The second one is going to be heavier than air gases. These gases tend to fall to the grade level, and that's where they become a little bit more complicated and more dangerous. They have been heated sufficiently to decrease its density. The cloud could behave lighter than air. So all of this is things that we need to look into. So we're going to look into ignition sources, where they are located in terms of elevation, and that's going to be something that we talk about when we talk about the classification drawings that we're going to talk about. There is also one that is applicable to all densities. As the gas diffuse in the surrounding air, the density will approach the density of the air, right? As you start heating the air, you start heating the mixture, that's going to behave a little bit more of that. There is another classification that falls under 4.2.4, which is for compressible liquefied gases. These gases are normally stored above their normal boiling point, but kept in a liquid state by pressure, right? When released, they immediately expand and vaporize, and that creates a large volume of a cold gas. Then that cloud becomes a little bit more of a behavior or heavier than air kind of gas. And of course, we have cryogenic. Cryogenic liquids are really stored, and it's the same idea. So we make small spills that will vaporize immediately, and then the larger spills may stay in that same state because of the amount of heat that you're gonna need to actually vaporize that. So some of those systems include anhydrous ammonia, propane, ethane, ethylene, propylene, LNG, and so far on. So those are all into there. So how do I know what I'm gonna do, what kind of classification those are gonna be, right? So from class one, the combustible materials are divided in 4 class 1 division groups, A, B, C, and D, and 3 classes. So there's gonna be 2A, 2B, and 2C, depending on the properties. This table is an extract from 497, NFPA 497, that tells you exactly where this falls. So if you're gonna look into specifically a material, let's say we're doing an assessment with acetylene, then I'm gonna go over where acetylene is present in here, and I'm gonna say, okay, that's a class division group 1, it's a gas, and then it's gonna tell me the properties. What's the out ignition temperature? What's the LFL? What's the UFL? What is the density? What is the vapor pressure? So all of this is information that I'm going to use to then, when I'm going to go do the assessment, I'm going to be able to pull it out and figure out which of the drawings I need to do. So on the left, the first one, you have a leakage that is located outdoors at grade for a material that is a flammable liquid. So what this drawing tells me is that I need to identify where the releases could occur in that system, and then I need to do the zoning based on what I have into this drawing. That's what it is. So it's going to be a class 1 div 1 zone 2, and then you're going to do the same for the flammable liquid for compressed gas, which is the picture on the right. So it's the same idea, it's just a compressible gas, and that's gonna fall in a class 1 and then div 1 or div 2. And you can see exactly if you have a below grade sump, that's gonna be a division 1. If I don't have a sump, it's all like out, and even my sump is on the air, then I do this around the 15 radius, as I can see in there. So this is basically how we're gonna carry the electrical air classification. We need to figure out which material, where they're gonna fall, and what is gonna be the drawings that we're gonna need to classify this based on. So the first step, of course, is for an existing facility is to go in and actually make assessment about where can I have the releases. Every point where I have a flange, a valve, it's a weak spot that we need to consider, for example, that there is gonna be a release at that point. And there's other things that we're gonna consider as part of it. The next step that we do is we're gonna do air classification now for dust. Then we're gonna go into 499. That's gonna make that we need to be sure that the combustible dust that we have, it has solid particles that are 500 microns or smaller. If they are bigger than that, then we're gonna need to consider, we don't need to consider them, right? So for us to have ignition of a dust cloud, let's go back a little bit to what we talked not too long ago, but we need to have the air, or basically the oxygen. We need to have the material itself, and we need to have ignition. The ignition could be electrostatic discharge, electric current, a spark, anything that can actually ignite that, right? So this is one of the things that are important. The next important thing is the material form, right? The dust discharge or leaking from the equipment will need to exist in the air and will need to result in an accumulated dust layer. In some cases, both the cloud and the layer could exist simultaneously, and that's what we talked about on a previous webinar about like the secondary explosion, which is the more damaging one. So that's where it becomes very important that we do good housekeeping. We do not have layers of accumulation of dust, etc., etc. So the second thing that is important in that is the size, right? The size and density of the dust particles are very important to actually do include that. And of course, the one other point very important to us is the combustible dust clouds. So we need to be sure that the combustible dust clouds are potential to cause significant overpressure or explosions when ignited. One is a small, very small quantity that combustible dust is not very reactive, then we don't have such a bigger issue. The same idea is if the particles are big, we're not going to be an issue with that because they tend to be a little bit bigger. And of course, the combustible dust layers. So that's also not only the combustible dust cloud, but the layer could cause a problem for us. So we need to include this into our assessment, right? One thing that is important to highlight is that dust accumulations also impact the area classification. When we talk about DHAs or dust hazard analysis, we talk about like dust accumulations and we talk about this, but for the electrical area classification is also needs to be considered. So we need to be looking into where those layers are formed and what is the impact, right? So similar to what we saw for flammable vapors and liquids, we also have the division in terms of classification. So we have the same idea that we have for them for combustible groups. So we're gonna have group E, group F, and group G. Group E is basically atmospheric containing combustible metal dust, including aluminum, magnesium, commercial alloys, and other materials. Group F is atmospheres containing combustible carbonous dust. So more than 8% of the Triton intrepid volatiles, right? So there is a ASTM standard that actually talks about this, and that's going to be D3175. It's going to tell you exactly what falls in there. So not as a simple coal, petroleum coal, coke dust, all of this is included in there. Group G is atmospheric containing combustible dust that are not included on E and F. That includes flour, grain, wood, plastic, chemical, a variety of them. Well, similar to 497, 499 has a list of those classifications. So what we do is we go into 499 to retrieve the information about what do we have, what division group we're gonna fall into, and then we take into what they are. Similar to what we have before, they have layer or cloud ignition temperatures, they have different things. Dust tends to be a little bit more specific than the general hydrocarbons like we do in 497. So a lot of times we're gonna get the layer or cloud ignition temperature, we're gonna get KST, we're gonna have all those properties, not necessarily out of 499, but out of a testing that is a requirement of a DHA. So we have the information here. If it's not tested, if it's not fully complete the testing, but it's something that we do in combination normally. So similar to what we saw for 497, in 499 we have also the diagrams that we're going to classify this based on. The left figure, which is figure 6.10 out of the 499 standard, is group F or G dust. It's for indoor, unrestricted area, or open or semi-closed operating equipment. So basically means that this equipment could be a hopper, for example, that you're gonna have it, it's not a closed system. So the one on the left does group F and G. So if we got a dust that is, for example, wheat, we're gonna use the one on the left. If we got aluminum, we're gonna use the one on the right. So that's basically the same idea. And you got class 2 division 1 and class 2 division 2. So that's basically how we're gonna apply this assessment. All right, so with that, how does it work, right? So how do we make this? So the hazard area classification helps us prevent explosion in industrial sites, right? And how do we do this? By a structure system. First, we identify which is identification of the zones that we have. Then we evaluate the likelihood and the not only the likelihood, but the duration of such conditions. And we assign zones or class on this likelihood, which directly influence the type of safety measures and equipment that we require, right? So great. So what is the practical approach that we do, right? So the first step is we do detection and assessment. So we basically begin by going through a thorough assessment of the process and materials to identify where exposed atmospheres may be. This involves understanding both the substance that we have and the operation conditions. The next step that we get is the zoning, where we basically divide each one of those areas and we specify them zones or classes and divisions according to the frequency and how long those hazardous atmosphere are there. Then we can actually, based on these classifications, we can define which equipment we're gonna need, which can be explosion proof, flame proof, intrinsically safe. And then we can also determine what isolation we need in prevention, right? In many cases, what is gonna lead is that we're gonna do local specific areas where equipment needs to be electrical intrinsically safe. And then from that point, we also have into the work practice, right? So with the work practice, what we have is that we do basically tell, okay, here's if we're gonna do hot work, the system cannot be working or this dust cannot be present, and this kind of things are part of what we do as work practice. And of course, last but not least, we have our compliance and ongoing risk management. So for that, we do regular reviews, we do training, we ensure that new hazards are always considered and the staff knows what equipments are safely within the classified areas. So that's basically what it is. Then we ask ourselves, why are we talking about going beyond zoning? Why do we need to go beyond that point that we're talking about, right? So there's a couple things. The strict zones is going to limit access, and sometimes the whole room can be zoned. So that means that the whole room needs to be intrinsically safe. That whole room cannot have ignition sources coming in and out, which sometimes for operations become a little bit of a complex situation. So what will happen is two things, is that either we make all equipment require meet the requirement for this specific location, which can create not only cost but also complexity for maintenance. And then what happens is that it end up being like very complex, very cost efficient, very cost inefficient, and then we end up with like something that is extremely conservative. Then we ask what can be done, right? In these cases, there's several things that can be done. One of them is that NFPA standards allow us to, as long as this ventilation provides us that there is not enough vapor or not enough dust to actually make that a combustible atmosphere, we don't need to zone it. So that ventilation study could be one thing. Another thing is like, okay, we did our ventilation is not enough. Okay, we can force the ventilation in this room. We can actually do a HVAC system that will remove that material from their location or be increasing the circulation in a way that this is dispersed enough that is below threshold that we did. Let's say that it's still there and we still want to be sure that then we can do dispersion modeling. That will tell us basically what is this range that this cloud can occur inside this location. Is that a concern or is not? The next step that we can also take is a risk-based assessment. So rather than just simply taking and saying, okay, this is my classification, this is my assessment. Okay, how likely it is that we're gonna have this dust present in there? How likely it is that we're gonna have this vapor present in this part of the process? Okay, then we look into likelihood of failure of equipment. And all of this is things that we can do to actually make this a risk-based decision and not anymore just, okay, here's the worst case that we can have. All right, so let's jump into some practical examples, right? So what happened in one of the studies that we were carrying is that he ended up like taking simply just what is our class 2 division 1 definitions and we put it in there. This is the impact that created. So the whole room was a class 2 div 1 zoning, which created a little bit of an issue for the client. What we end up doing is that we end up carrying just a simple ventilation study that actually proved that we would have enough ventilation into this room to actually remove that out of there. So that allows us to have a little bit more of a proper assessment and a less conservative zoning into this for this client. The next study that we want to highlight is a very similar one, but what happened is that we couldn't do just by the ventilation study, because when we came on site, there was layers of dust, very thick layers of dust, a lot of dust being in the room. So what needs to be done is improve the housekeeping and the ventilation study. Later on, we came back and the accumulation of dust was not as much. And you can see based on NFPA 499, if you have a dust layer there, if you have no visible dust cloud and the dust layer is less than 1/8, you can actually remove the classification too. So all of this is things that we did work to actually be able to actually change from a div 1 to a div 2 and so far on, which allows a lot more opening and a lot more option, right? So we went from a class 2 div 1 to a class 2 div 2 with those studies combined. And if there was another port to actually make a little bit more of a forced ventilation, we could have actually been able to remove altogether, but that was enough for the client at this stage. Then moving from dust to actually flammables, vapors. So we had a very similar thing that actually happened, that the building was all zoned. Part of it division class 1 division 1, part of it class 1 division 2. What happened in there is that we carry on a ventilation study, and that was done with CFD in this case because it was a little bit more complex, not as simple. A lot of the dust ventilation studies, they need to be carried as well with CFD. We currently have empirical models are not really set up so well for dust. There's a lot of consideration that we need to do. So, but the ventilation study is actually something very simple and very quick to do in CFD, so it's not as cost prohibitive as some of you guys may think. It's quite straightforward and quite easy to do. And then what basically we managed to do is take and remove the classification altogether because there was no vapor present. So in the end of the story, as long as you prove that the ventilation is adequate, you can actually remove classification for that. So in summary, based on what we're talking about, if we just use a standard area classification, that's the first step. We evaluate the systems, evaluate the mitigations, and then if it became an issue, we need to look into a risk-based area classification, which will reduce the conservatives, look into the proper evaluation of the mitigations in place, and then in some of those instances, we can remove that very strict classification that we end up with. So in Sigma, we try to actually help you guys with not only what you guys need, but also trying to find a way to fit and what your means are. So we can help you from every stage of the process, from concept design all the way to existing facilities and decommission. We have done plenty of area classifications from concept selection all the way to existing facilities and revalidation of hazard area classification. We have over 30 years of expertise in the area. We've developed not only the hazard area classification, but also evaluated the mitigations and proposed solutions that fit your need. Our approach, as I mentioned, it goes with the standard and combines with advanced techniques like CFD, this ventilation studies and other things to actually meet your client need and not end up with something very conservative. And then, of course, we have a very tailored HAC or hazard area classification solutions that balance the safe, the compliance, and the budget while we try to optimize the life cycle, of your facility. And with that, I turn back to Mark. Thank you guys for your time.
Thank you, Vinny. If you have any questions, please add them to the questions section on the right, and we can get you an answer. First one we have here, Vinny, is everyone required to complete a hazardous area classification?
So OSHA says that you need to classify. So the same classification and zoning falls under the OSHA standards in there. I can go back quickly to point exactly which ones we're talking about. But OSHA 29 CFR 1910-307 and 1926-407, they do tell you how to do hazardous area classification, basically. So yes, you're required to do area classification. Of course, if you fall under OSHA regulations.
Excellent. All right. Thank you. Is there, how often should the assessment be done? Is there any timetable on that?
It's not a timetable. Usually what I say is that you should revisit, it should be part of your management of change, that if you make a major change, the same way that triggers you to redo your HAZOP, your facility siting, you should revisit your air classification because that may change. Aging equipment makes a problem too, so it should be something that even though it's not prescribed to be constantly done, I would say that you don't need to do as often as you do the HAZOPs and so far on, but it should be redone. If you have a facility that is 20 years old and haven't revisit your air classification, it's probably a good timing, a good idea to do it. All right,
All right.
there is one other here about, does 497 and 499 list potential leak sources you consider in your religious assessment? The short answer is not really. It's basically something that comes with experience and comes with you going around and figuring out what could be and what could not be the potential leaks. But everywhere we can have fugitive emissions, a lot of times, again, it goes back to flanges, valves, moving from one equipment to another. All of those are more likely that will be releases in there. So that's the idea. So I have another one here that's very interesting. That we have an electrical panel which is located in incompatible location. How to reduce its risk? In particular, this panel is limited by cables. Is that a practical approach to solve such issues? It is a little bit a complex situation because a lot of times the panels and all, it's the moving them becomes a little bit of a complication. But I'll happily reach out and see if there's something that we can help you with. I'll reach out offline to see if we can have a quick chat and we can figure out what can be done for that. So for substance not included in the list of 497, how to identify the zone, we use similarity, but 497 is mostly good about covering those. They have majority of the flammable material, so it's gonna be a little bit hard to not have it, but I have phase one and we just make an assumption about with the client and talk with them and say, hey, it's by looking into the vapor pressure, looking into temperature, boiling point, melting point, is similar to this material. Are you okay if I use this? So that's how we end up with that in this situation. So the best way to create to document data decisions used to create the HAC drawings is to actually put a report. The drawings itself, they're great, they're visual and all, but the report will list all your assumptions, all the decisions, all the agreements that were made. So as part of our assessment, we always put in the reports to be there and there. There's another one here, which is, does the HAC also apply to oxidizing substances, oxygen, peroxide? Although these materials are non-flammable, they can promote the combustion of ordinary materials such as lubricants. Not directly. That was a very good question, by the way. It's not directly. It's one of those that they are not going to do it. So what you're going to do is look into the ignition of the other materials. So they're going to be a catalyst. They're going to be an ignition source as part of your assessment. They are not going to be hazardous area classification per se for them, but you're going to need to include because they're going to be an ignition. So directly, you don't do a hazardous area classification for them, but they become part of your hazardous area classification study. So that was a really good question. Does NFPA not consider the evaluation of mechanical equipment within the classified areas? We only look into electrical area classification for those. So the mechanical equipment, if they can provide a source of ignition, and I'll give you a very simple example on the dust industry. It's like elevators, conveyor belts, if they are metal, they actually can create sparks. So this is one of the things that we do take when we do this decision. So when designing a CNG and LPG autogas servicing and installation facility, would NFPA 497 and NEC 505 and 506 be the most advisable standards to follow? Absolutely. They will be very valuable for you to make assessment about your areas and where you need to have control of ignition sources and so far on. So absolutely, yes. And I think that was the last one.
Looks like it. A lot of good questions.
A lot of good questions. And if I told you that I'm gonna reach out to you, as long as your registration has an email, which I believe you guys have, I'll reach out and we can set up a Teams call or something to go over that and discuss that option.
Yeah, and always feel free to reach out to us if you didn't get a chance to ask a question. We're always
Yeah,
happy to set up a time.
I'll put it back, our contact information, so you guys have that. So give a minute or so. So if you need to reach out, reach out. Those will come to Mark and he can put me in the loop if need be. Appreciate
All right.
everybody's time. Thanks a lot for taking a little bit time of your busy day and listen to us.
Yes, thank you for joining us for our discussion today covering hazardous area classification. And once again, should you need any assistance with testing and process safety support, feel free to contact us. You can find us by email at info-us@sigma-hse.com. We look forward to being a resource to you and have a great day.